Okay, so we're going to start with a little review of some of our power rules. Let's start with, if I had 2 to the third power and I multiplied by 2 to the fourth power. Okay, 2 to the third times 2 to the fourth. If you put this in your calculator, does everybody know how to put in 2 to the third times 2 to the fourth? So on my calculator, if you want an exponent, is this yours? Yeah. If you want an exponent, this button right here beneath clear gives you the exponent. So you could put 2, click the button, 3, tab over, times 2 raised to the fourth. Do I need to pull that up on my computer where you can see it? Does everybody know what I'm talking about on here? 128. Does everybody see that? Yes, sir. Okay. So if you were to multiply this out, that is 128. And why would you ever need to know a rule for how to multiply exponents? Just put in your calculator. Okay, well here is the rule, and I will tell you why you may need to know it in certain situations. Anytime we are multiplying powers. Okay, does everybody know what a power is? Okay, so let me do a little bit of explaining here. If I look at, let's just look at 2 to the third. The 2 is called the base. The little 3 up here is called the exponent. This whole thing is called a power. So when you have a base and an exponent, that's called a power. So right here on this problem, we are multiplying powers. Everybody knows what I'm talking about when I say that now. Multiplying powers. Do they have the same base? Yes, both of them have a base of 2. So the rule is when you are multiplying powers with the same base. Does this fit that criteria? Yes. Multiplying powers, both have a base of 2. Okay, here's the rule.
You always have to have the same base?
This is the rule. You can use it, yes, when you have the same base. You keep the base the same. Add the exponents. So right here, 2 to the third times 2 to the fourth. Multiplying powers with the same base. We keep the base the same, 2. We add the exponents. 3 plus 4 is 7. So 2 to the third times 2 to the fourth is the same thing as 2 to the seventh. Just to verify, put in 2 to the 7th in your calculator. It is 128. Right? And I mean, if you think about it, and again, you don't have to write this part down. This is just, I want you to think. What does 2 to the third really mean?
You're multiplying times 2 and 3 times.
Right. You are multiplying 2 3 times. So 2 to the third is 2 times 2 times 2. And then we want to multiply this by 2 to the fourth. What does 2 to the fourth mean?
You multiply by 2 4 times.
So really, what am I doing? I'm multiplying the number 2 7 times. That's why we can add the exponents. I'm taking the number 2 and I'm multiplying it by itself 7 times. Or do you see visually what it means, how it ties together? Have you guys seen this rule before?
I think I have.
You might have seen it in 8th grade. Now we're fixing to start doing a lot of math with exponents. So we need to get comfortable with this rule. I'm just going to make some up very quickly. I want you to see if you can answer them. If we did 3 to the third times 3 to the 8th, what would that be? 3 to the 11th, right? Keep the base the same, add the exponents. What if I had 3 to the 5th times 3?
It just be. No, it wouldn't.
So if I don't have an exponent, right, the second 3 doesn't have an exponent, I can put an understood 1. It's to the first power, so I can turn it into a power. So this is 3 to the 5th times 3 to the 1st, which would be,
So, there's always an understood 1.
it's an exponent on every number.
That's crazy. Like, you don't think about it like, but there's an understood 1 everywhere in the problem.
In front of the x as a coefficient.
It's crazy.
Mm-hmm. 3 to the negative 2nd times 3 to the 3rd.
That'd be deep.
Just keep 3, right? Yeah.
That would be 3 to the 1st.
Would you have to put the 1?
You don't have to put the 1, so just put 3. All right, what about 4 to the 2nd times 5 to the 2nd?
Would you add the bases? Or would you multiply?
What's the only rule you know?
If the base is the same. Oh.
If you're multiplying powers
The base is
with the same base. Do they have the same base?
No. That's all.
So I can't simplify it using my exponent rules.
So like on a test, we didn't have to write that.
You could leave it like that. Or if you want to, 4 to the 2nd is 16, 5 to the 2nd is. Then right, you could multiply it out that way.
Oh, okay.
But there's no way I can simplify this because they have different bases. Okay? Everybody good here?
I thought it'd be like, have to find least common multiple or something.
The calculator does it.
Yeah, it gives you 16 times 25, which would be 163, 20, and 80, 400. Is that right? So it does the multiplication. Your calculator, if you put this in, it's not going to give you 3 to the 6th either. It's going to give you that number. But I'm showing you with numbers because guess where you have to use these exponent rules? X to the 2nd times x to the 5th. Now then, are these powers?
Yes.
Do they have the same base?
Yes.
So you can keep the base the same and add the exponents. You can't put that in your calculator. Your calculator will not do x squared times x to the 5th. You have to know the rule to be able to work that one out. Okay, so I know some of you think, I'm never going to use this rule. I'll just put it in my calculator. You can't. All right, the next thing I want to talk about, and this is something that this book assumes you've already seen. Maybe you have, maybe you haven't. All right, we've kind of talked about if I have 3 to the 4th power, what does this mean? Like, how could I write this out?
3 times 3 times 3 times 3 times 3.
So we understand what an exponent means. We understand how it's used. Okay? What if I had 3 to the negative 4th power?
You just
Wait. If, okay. So it's the same rule, but like negative times negative is a positive, and then
No.
would it not be that?
No. So what you're thinking is, if I had negative 3 to the fourth power, this is negative 3 times negative 3 times negative 3 times negative 3. Remember, the number tells me how many times I'm going to multiply.
Yeah.
I'm multiplying 4 times. How can I multiply number negative 4 times? Okay? Intuitively, that's correct. This would be a division problem because it is a negative exponent. Okay, but here's the way we think about it. Because you're not really doing 3 divided by 3 divided by, it gets a little confusing. What we do is anytime you have a negative exponent, we can rewrite it in the denominator. So say this is 3 to the negative 4th. Well, this is understood to be over 1. Right? I can put any number over 1 and make it a fraction. What I can do is I can send a power from the numerator to the denominator, and it will change the sign of the exponent. So this would be 1 over 3 to the positive 4th.
Why would you do that?
But this is what you said you were doing. What did you say the negative exponent meant you were doing?
Oh.
I'm dividing by 3 4 times.
Okay, so then you would remove that top.
Because what we're really doing is we're doing
Okay.
1. There's an understood 1.
Yeah.
And I need to divide it by 3 4 times. That's where the 3 to the 4th comes in.
So that's why it's like a really small decimal, like that.
Yes. And you can, if you click, which I don't know if the calculator will make one this small. If you click math, frac, enter, see if it'll.
1 over 81.
Because 81 is 3 to the
Oh.
4th power.
Dang. That's crazy.
So what Tay was saying, Tay put this in his calculator, 3 to the negative 4th. Right, so let's do that. 3 to the negative 4th.
Make sure you use the actual negative button.
Use the negative button, not the subtract button.
It'll freak out on you.
You should get 0.01234567 9.
Yeah.
Everybody see that? Now, I can turn this into a fraction. Click the math button. Click frac, which is the very first one. So you'll click enter, and you click enter again. No, 3 raised to the negative 4th, math, frac, enter. Yeah, don't change it. Everybody get it? Can you help somebody else?
What was she supposed to get?
1 over 81.
You'll get 1 over 81.
Mine's wrong.
Because what is 81? It's 3 to the 4th. Okay?
Math and what?
Math, frac, for fraction.
Where's the friend?
Look, this thing. Yours birthday. You already got it.
So 1 over
Because you put it
81
over
would be
1.
the
That's
answer?
all. Huh?
So that would be the answer?
This is what we're working on. If I had 3 to the negative 4th, I could rewrite that as 1 over 3 to the 4th. That's your new exponent rule.
It's basically just simplified. You're just doing it simplified.
Correct. I'm not interested in the number answer
It's
right
just
now.
how you can simplify it.
Correct. We're simplifying expressions
I got you.
because we're going to eventually be solving equations that have exponents. So if I had x to the negative fifth power. How could I write this? 1 over x to the fifth. Right, if I had 1 over 2 to the negative third. Now then, my power is in the denominator. Everybody see that? So how can I change the power so it's no longer negative? I can move it to the numerator. And that would
You
be,
move the base with it too, like that whole unit you'd move.
Yep.
Right?
Yep.
Okay.
yep, the whole power.
The whole power.
The whole power.
So will you ever get an answer that's like that, like 1 over 2 over to the negative third?
Well, a lot of times when we do these problems, or when you first learn them, they will give you negative exponents and they'll tell you rewrite it with an exponent, but they can't be negative. So you might have to move it from numerator to denominator to make it positive.
So you won't ever get an answer with a negative.
No, because not in Algebra 1. In Algebra 1, let's just make it a rule. Let's always make it positive.
So
I had a hard time saying that because in pre-cal, we have negative exponents. And it's part of it. We just know how it works. But for now, while we're learning it, let's try to make them all positive. That way we get used to moving it as we need to.
do you want us to always write it over or under 1 or whatever? Or just leave it out because it's understood?
Yeah, you don't have to put that back over 1, but you can. All right, what's this one? 2 to the fifth divided by 2 to the negative second.
Oh. Okay.
2 to the third.
No. Okay, so first you would switch that negative power to the numerator and make that positive.
So I can move this power to the numerator.
And then that top one
2.
would be...
It stays.
Yeah, and then you would add on to that 2 to the positive 2, and it'd be 2 to the 7.
I can do that.
You gotta switch it around. So that wouldn't... So the top one, it wouldn't change to negative or whatever. You only, like...
If I move it to the denominator, it could become negative. But because it was in the numerator, I didn't drop it. I just moved the one in the denominator to the numerator. And this was already there. So I moved it up there with it. These are two different terms,
Yeah.
two different powers.
Yeah.
Only one of the powers was negative. So I took the negative power and moved it to the numerator. Because it's independent of this one.
Oh.
I didn't have to flip the whole fraction.
You just moving that top
I just moved this power
I got
to
you.
be with the other power. And I can move a power, just change the sign if I move it from numerator to denominator.
So that'd be the same case with if it was 2 to the negative 5th power over 2 to the positive 2 power.
If I wanted my answer to be a positive exponent,
You just take that
I
down.
could move that one to the denominator. That means there's an understood 1 on top because I have nothing left. And I would have 2 to the 5th times 2 to the 2nd.
Which is 2 to the 7th.
Yep.
Okay.
So what if the numerator and denominator both of the exponents are negative?
Like, if I get this as my answer, if you wanted to move this back to the numerator, you could.
It'd be 2 to the negative 7th over 1. Or just 2 to the negative 7th.
Right now, when you're in Algebra 1, we typically say you cannot have a negative exponent as your answer. So we would say leave it like this, but as you get in upper level math, we would definitely take that as an answer.
And then add.
So if I had 2 to the negative third over 2 to the negative 8th.
Ooh, big number. Alright, so switch both of them. Switch.
So I'm going to move this power to the numerator,
Yeah, so the numerator.
move the other power to the denominator.
Both making them positive.
So this is now 2 to the 8th over
2 power,
2 to the third.
and then you would add those. No, you would.
So this brings me to the next rule. This is good. Are they both positive?
Yes, they're both.
All right, so let's think about it, see if we can figure it out on our own. What happens when we multiply powers with the same base?
Add them.
You keep the base the same, you add the exponents. What am I doing here? I'm dividing powers with the same base.
So would you subtract?
You keep the base the same and you
Oh,
subtract
dang.
the exponents. So this could be 2 to the 8 minus 3, which is 2 to the 5th.
Dang.
And now just to show you visually, what does 2 to the 8th mean? 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. And this is being divided by 2 to the third. What can I do when I'm dividing? Do you remember reducing in division?
Yes.
What happens if you divide 8 by 8?
Turns into 1.
That's just 1. I can just cancel those out as 1. So here, if I'm dividing this 2 by this 2, this 2 by this 2, and that 2 by that 2, what do I have left? 5 2s. I'm multiplying 2 by itself 5 times. To the 5th. It does?
Could you leave that up there for just a minute?
I will. All right, so the next thing I want to do is I kind of want to teach you this for a second, and then we'll start getting into the lesson. All right, this is kind of a review of all stuff that you should have done. Maybe you have, maybe you haven't. I don't know. If we're not any good at it, I can give you a lot of worksheets on it, but I don't think this requires a lot of practice, right? I mean, you should know how to do it for me just explaining it. Huh?
All we're doing is just dividing.
No, that is the stuff you should have already known.
No, I was just asking.
Yeah. And like I said, if you don't know it, it's not that big of a deal. I don't think it's that's why I'm saying it's not a thing that I don't think it needs to take all day to review it. Right, but I do want to show you this part because I think it's cool and can kind of tie stuff together. So you don't have to take a note on this part. This is not something you're going to be tested on, but it's something I think is interesting with math. So you know your place values, right? What are the place values? Let's just go to 1,000,000. Okay, what are our place values?
One,
You have your ones place,
10,
10,
Hundreds.
100,
Thousands.
100. Hold on, let me write a little bit bigger so we can see.
1, 2. Whoa, too many.
Yeah, I probably did 2 million. Okay, so we started with the ones place, the tens, hundreds, thousands, 10,000s, 100,000s.
It just keeps on moving.
Yeah, we could do this forever. Millions, 10 millions, 100 millions.
Hopefully there'll be my bank account one day.
Better get to work.
Yeah.
Okay, so
Don't ever say that again.
does anybody know what our number system is based on? Every number system has what we call a base. Think about what we just talked about with powers. Powers have a base, an exponent, and the whole thing's a power. So what are the bases of our number system?
Decimal.
Okay, well, you're in the right ballpark again. What's the prefix?
Deci.
10.
Because how long's a decade?
10.
10 years, right? Prefix, desa is 10. This is a base 10 number system, which means 10 we can write as 10 to the first. 100 is 10 to the second. 1,000 is
10 to the third, fourth, fifth, sixth, seventh,
and so on and so on and so on.
so then it wouldn't be. Wait, if we can go on forever, why do we only count them?
We don't. Just like you can
So
talk.
where did 10 to the whatever power come from?
10 to what power?
10 to like the first, second, third. Like, why do we come up with the number 10 as the?
Okay, well we chose 10 because we have 10 fingers.
Oh, okay.
We were able to carry over from one to the other. Alright, the thing I want to show you is, well, what would the next place value be?
It's the negative.
Because 10 to the first is 10, 10 to the second is 100, this is 1,000, 10,000, 100,000. All these exponents tell us how many zeros there are. How many zeros are there in a 1?
No.
So the ones place is
It's 10.
10 to the 0. So I don't know if you know this, anything raised to an exponent of 0 is 1. So like 2 to the 0 is 1. 5 to the 0 is 1. A million to the 0 is 1. So this is 10 to the 0, this is the ones place. Right? Is this where our place value stops us?
No.
No, we have a decimal, and then what's the next place value called after the ones?
So 10.
Tenths. And then next is hundredths. This is good enough. Thousandths. 10,000ths. 100,000ths.
I say millionth.
Millionth. 10 millionth. 100 millionth. Look at our powers. If I follow, what would the tenths place be?
1. 10 to the.
This was 10 to the first, 10 to the 0.
Oh, that. Oh, yeah, because it's behind.
And how can you rewrite this with a negative exponent?
10, okay.
Oh, it's the tenths place.
Makes a lot more sense.
Why isn't there a once place? Well, your teachers couldn't explain it to you because you didn't understand negative exponents. Now you can. That's why it's tenths is next. Hundredths.
1 over 10. Oh, and then.
Thousandths. You don't think that's as cool as I do? That's fine. I'm a math nerd.
No, my mind's blown right now. I don't have any more room for soccer.
That's how I do on math. I don't need no calculator.
I asked my little brother last night what was 10 divided by 2, and he started counting.
Which one?
I said, there's nothing to count.
Can you count how many times I said it wrong?
That'd be 1.1. Wait, if you, was it put the two,
He was on
or
like
swap them
10 like
and make
10
it,
times away.
You're probably not going to guess it. It'd be hard to just figure out probably. Okay, so now I've got 3 raised to the 1/2 power.
I'm already not liking this.
This is already hard.
So just to review, what is 3 to the second? That is 3 times 3. What is 3 to the third?
3 times 3 times 3.
3 times 3 times 3.
What is 3 to the fourth?
3 times 3 times 3 times 3.
Okay, but what does 3 to the half mean? You can't multiply 3 by itself half a time.
3 times
3 times.
No,
3 to the
if you're doing half of 3 when you're getting 1.5. But we're multiplying 3 by itself half a time.
How do you do that?
Exactly. We can't make sense of it. So we need to define a new meaning. So whatever our new definition is, we want it to follow the same as the power rule. So let's very quickly review what the power rule is. Because I'm going to say you probably don't remember it either. All right, if I had 2 to the 3rd to the 4th, this is called the power rule. What am I even trying this for?
We appreciate your effort.
Yeah, I mean, there's only so much I can do. 2 to the 3rd, all to the 4th power. We can think about what this means. This would be 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Right? I'm multiplying 2 to the 3rd by itself 4 times. So what would 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd be?
1,096.
I don't care about the number.
It looks what?
It's 2 to the.
It is 2 to the 12th. How did you get 2 to the 12th?
Yeah.
You could add the exponents, right? I'm multiplying powers with the same base. So that's what we're working back towards. This is the power rule. When I have a power raised to a power, we can multiply the exponents to get 2 to the 12th. Okay, that's the power rule. We may need to just spend a whole day working on power rule if you guys aren't familiar with that. Because you got to remember this. This is not going away. That's the power rule. So we want this to work. We want this to work for all exponents. Power to a power, we multiply. So here's the question. What if I had, and this is something, what if I had 3, come on.
That's what I was saying.
What if I had 3 to the 1/2 power and I decided to square that?
It would be 3.
We should get 3 to the 1/2 times 2, which is 3 to the 1st, which is 3. So when I multiply 3 to the 1/2 by itself, right? Because that's what's really happening. 3 to the 1/2 times 3 to the 1/2, I should get 3 to the 1st. So really I'm asking, what number times itself is 3?
3. No.
All right, let me do it with a different number. Let's talk about 4 to the 1/2. If I did 4 to the 1/2 and I squared it, that would be 4 to the 1/2 times 2, which is 4 to the 1st. So what number times itself is 4?
2.
Because when I multiply 4 to the 1/2 times itself, I should get 4, which means this number should have been 2. Let's do it one more time. Let's do it one more time. If I had 9 to the 1/2 and I squared that, we should get 9. So what number times itself gave me 9? No. No.
Oh yeah, 3. I
forgot 3 times 3 equals 9. Oh, yeah.
Whoa. I knew that.
I go brain dead sometimes. It's not your fault.
I've been off the ADHD medication for 5 years.
I've been off it before.
So when I have 3 to the 1/2, what I really can do is I can rewrite this as a radical.
I hate those.
I hate that.
The base stays inside. The number on bottom of my radical is what I'm taking the root of. So because this one had a 2 on bottom, I'm taking a square root. If it was a 3 on bottom, it would be a cube root. 4 on bottom would be a 4th root. And then the number on top, we can write that as a power to the inside. So this would be taking the square root of 3 to the 1st power. So what number times itself is 3?
1.732.
Which-
Oh, 8. Oh, 8.
Which we just leave it as radical 3.
Okay.
Because radical 3 times radical 3 is,
2.
What? What?
Wait, hold up.
Oh, that makes sense.
That's easy.
let me show it to you with a better number.
Okay, the square root of that number times the square root of that number is going to get you the same number.
Yeah, let me show you with a number that works out. If I did the square root of 4 times the square root of 4,
Which is 2 times 2. That's going to equal 4.
the radicals cancel out.
Yeah.
If I did the square root of 9 times the square root of 9,
That's going to be 3 times 3, which is going to equal 9. Because the radicals cancel out. Oh, yeah.
that's what happens. So right here, if I multiply radical 3 times radical 3, my answer is 3. Are you following the logic?
Yeah.
So if I had to write 2 to the 1/3,
It'd be not cube. Yeah, cube. Cube's the 3, right? Or is that
cube root
cube?
of 2.
And then
So it'd be.
would you do it 3 times that time if you wanted to get the?
No. I was explaining to you why it works the way it does. I may have confused you doing it that way. 2 to the 1/3 power simply means what's the cube root of 2. So like the last problem, if I had 2 to the 1/2 power,
It would just be radical 2 times radical 2.
no.
But
That's what I said. I confused you. 2
I got it.
to the 1/2 power is radical 2, the square root of 2.
Oh.
No way.
Really? Okay.
So.
But I thought you just left it as.
And if I had 8 to the 1/4 power,
That's
the 4th root of 8.
yeah.
Okay.
What?
That makes sense.
I got this.
I was trying, and I may have done a bad job. I was trying to explain to you that we needed the power rule to work. So we didn't know what 3 to the 1/2 power was.
So you were just trying to explain how you get.
So I was explaining the logic behind it.
All right.
But now, if you see 3 to the 1/2 power, you can know it's just the square root of 3.